Ever wondered about the groundbreaking discoveries in the field of chemistry? This fascinating realm, an intricate blend of science and art, has been unraveled over time by some of the brightest minds on the planet. Today, we shine a spotlight on some of these extraordinary individuals, the Nobel laureates in chemistry. The Nobel Prize, established in the last will of Alfred Nobel, the inventor of dynamite, is a global recognition of outstanding contributions to humanity. In the world of science, it is the highest accolade, a testament to tireless curiosity, relentless pursuit of knowledge, and the audacity to challenge the status quo. These laureates have not just expanded our understanding of the chemical universe, but their discoveries have touched our lives in countless ways, from healthcare to technology, from environment to energy. Chemistry is an exciting journey of discovery, filled with elements of surprise and reactions that leave an everlasting impact. Let's kick off our journey with one of the most renowned scientists of all time, Marie Curie. A name that echoes through the hallways of scientific history, Marie Curie was a trailblazer in every sense of the word. She became the only person to win Nobel Prizes in two different scientific fields, physics in 1903 and chemistry in 1911. Her discovery of radium and polonium was nothing short of groundbreaking, and it was she who first coined the term radioactivity. Her pioneering work didn't just open up new avenues in the field of chemistry, it also paved the way for significant advancements in medical treatment. But our journey through the annals of chemical history doesn't stop here. Our next stop is the mid-20th century, where we meet Linus Pauling. Pauling's work on the nature of the chemical bond was a revolutionary stride forward, earning him the Nobel Prize in Chemistry in 1954. But Pauling was much more than just a brilliant chemist. He was also a man of strong convictions, unafraid to voice his political views. When offered the position of an ambassador, he did not hesitate to reject the offer, choosing instead to focus on his scientific pursuits and his outspoken stance against nuclear weapons. This stirred some controversy, but it also highlighted his staunch commitment to his beliefs. Marie Curie and Linus Pauling, two names that will forever be etched in the annals of chemical history. Their work laid the foundation for countless breakthroughs, and their stories continue to inspire scientists around the world. These pioneers not only advanced the field of chemistry, but also challenged societal norms and political views. Their stories remind us that science is not just about the pursuit of knowledge. It's also about courage, resilience, and an unwavering commitment to making the world a better place. The field of chemistry is not just for the boys. Meet Dorothy Crowfoot Hodgkin. A woman of substance and a trailblazer, Hodgkin defied the odds in a time when women were scarcely seen in the field of science. Her journey started with a passion for crystals and led her to the hallowed halls of Oxford and Cambridge. Hodgkin's work was nothing short of groundbreaking. She made significant strides using X-ray crystallography, a technique that allows us to peek into the atomic and molecular structure of crystals. This might sound like a small step, but it was a giant leap for science. Hodgkin used this technique to determine the structures of vital biochemical substances, including vitamin B12 and insulin. Her work not only advanced our understanding of these substances, but also paved the way for new treatments for an array of medical conditions. But let's not forget the significance of her being a woman in the field. Hodgkin shattered the proverbial glass ceiling, proving to the world that gender is no barrier to brilliance or achievement. She was a beacon of light for other women, inspiring them to challenge stereotypes and reach for the stars. Now let's transition to another game-changer in chemistry, Carey B. Mullis. If you've ever heard of the polymerase chain reaction, or PCR, you can thank Mullis. His invention was no less than revolutionary, transforming the way we analyze DNA. Imagine being able to copy a specific DNA sequence billions of times in just a few hours. That's the power of PCR. It has made gene mapping possible and opened up new frontiers in genetic research, from diagnosing diseases to solving crimes. Mullis's work was a game-changer, a veritable revolution in molecular biology. It's no wonder he took home the Nobel Prize in Chemistry in 1993. So there you have it. Dorothy Crowfoot Hodgkin and Carey B. Mullis, two remarkable scientists who left an indelible mark on the world. Their work revolutionized our understanding of biochemical substances and DNA analysis. From DNA analysis, we move on to the principles of evolution with Francis H. Arnold. Now, Francis isn't your everyday chemist. She's the fifth woman to claim the Nobel Prize in chemistry, and she did it with a touch of Darwinian flair. Arnold's work is centered around enzymes. These biological catalysts are responsible for speeding up chemical reactions in our bodies. But Frances saw beyond their natural function. She envisioned a world where we could harness these enzymes and engineer them to serve our industrial needs. So, how did she do it? Well, she let evolution do the heavy lifting. Arnold introduced mutations into the genes that produce these enzymes. She then used a method called directed evolution. It's like survival of the fittest, but for enzymes. The enzymes that were best at their job were selected, and then their genes were mutated again. This process was repeated over and over until the enzymes were perfectly engineered to perform specific industrial tasks. The implications of this are enormous. Arnold's engineered enzymes are used in creating biofuels, pharmaceuticals, and even in the production of sustainable plastics. In essence, she brought the principles of evolution into the lab and used it to engineer a more sustainable future. But the engineering evolution didn't stop there. Our next laureates took it from the lab to our pockets. Meet John B. Goodenough, M. Stanley Whittingham, and Akira Yoshino. These three maestros of chemistry teamed up to develop something we all heavily rely on today: lithium-ion batteries. Their work revolutionized the way we store and use energy, powering everything from our smartphones to electric cars. Goodenough, Whittingham, and Yoshino's lithium-ion batteries are lighter, rechargeable, and more powerful, making our devices more energy efficient and our world a little greener. Sustainable industrial processes and energy-efficient devices, all thanks to these brilliant minds. Finally, we delve into the world of gene editing with Emmanuelle Charpentier and Jennifer Doudna. These two brilliant minds took us to the frontier of science, where we have the power to rewrite the genetic code of life itself. Their tool of choice? CRISPR-Cas9, a revolutionary gene editing technology. CRISPR-Cas9 has been likened to a pair of molecular scissors. It seeks out a specific sequence in a DNA strand, then cuts it, allowing scientists to remove, repair, or replace a particular gene. The simplicity and precision of this technology have opened up a world of possibilities in genetic engineering. Imagine being able to correct genetic disorders at their source, or engineer crops to withstand harsher climates. These are not distant dreams, but tangible realities that the work of Charpentier and Doudna has brought within our reach. Their discovery has the potential to transform medicine, agriculture, and beyond. But with great power comes great responsibility. The ability to edit the book of life raises important ethical questions. How far should we go in modifying our own genes? What are the potential risks and unforeseen consequences of tampering with our genetic code? These are questions that the scientific community and society at large must grapple with as we navigate this brave new world of gene editing. The significance of Charpentier and Doudna's work extends beyond the laboratory. By winning the Nobel Prize in Chemistry in 2020, they became the first all-female team to do so. Their achievement serves as a beacon of inspiration, showing that the pursuit of knowledge knows no gender boundaries. In the grand narrative of scientific discovery, Emmanuelle Charpentier and Jennifer Doudna have written a pivotal chapter. Their work with CRISPR-Cas9 has not only changed our understanding of what's scientifically possible, but has also reshaped our perception of what we, as humans, are capable of. With molecular scissors in hand, these scientists gave us the ability to edit the book of life. From radium to gene editing, the field of chemistry has come a long way. A captivating journey indeed, through the lives and accomplishments of some of the most brilliant minds. Each one a testament to the power of curiosity and the pursuit of knowledge. We've traveled from the early days of Marie Curie, discovering radium and polonium, to Linus Pauling's groundbreaking work on the nature of the chemical bond. We've admired Dorothy Crowfoot Hodgkin's determination, breaking gender stereotypes, and Carey B. Mullis's innovative spirit, revolutionizing DNA analysis. We've seen Frances H. Arnold use evolution to engineer enzymes, and a trio of scientists develop lithium-ion batteries. And we've witnessed Emmanuelle Charpentier and Jennifer Doudna rewrite the book of life itself with CRISPR-Cas9 gene editing. These milestones are not just historical highlights, they're reminders of the vital role chemistry plays in our everyday lives and the endless possibilities it holds for the future. Stay curious, stay excited. Who knows, you might be the next to make a groundbreaking discovery in chemistry.